All right, so here we go, Luke. I'm going to give it my best effort on trying to explain this as simplistically as possible because it's kind of a big topic. Um, 1 second, I got to pause. Okay, so first of all, we are going to be doing in that lesson, I know it was called something like sinusoidal graphing or something like that. We're going to be graphing sine and cosine. I don't recall seeing tangent in the question, so we're going to be graphing sine and cosine as a function of x and y. Now in a minute I got some explanation to do. We're going to graph this equation, y equals sine x. X is going to represent angles, and y is going to be the sine of those angles. And I want you to think of, you know sine from our talk, like opposite over hypotenuse, okay? And I'll do a discussion of cosine too. But there is something else to talk about too. When you graph sine and cosine, you don't use degrees. You don't do, like 0, 30 degrees, 60 degrees, 90 degrees. You use radians. And we haven't talked a lot about that, but we did talk about this. And I think I compared it to you. I said, what would happen if all of a sudden today we stopped using the Fahrenheit scale to measure temperature and we went into Celsius? That would take some getting used to, when you're like, if it's 32 degrees Fahrenheit, like the other morning it was really cold and we're like, hey, it's 32, but if we're at a Celsius country, all of a sudden we're like, hey, it's 0 degrees outside. People would be like thinking that was immensely cold, when on the Celsius scale, 0 is 32 degrees Fahrenheit. So we're like that. So 180 degrees, that to be a half circle, is called pi on the radian measurement scale, 3.14. So here are some key, now you're going to notice I picked some of the really nice degree measurements, like starting out at 0 degrees. And I'm going to explain that too, but I want you to think about, I have a little coordinate plane with a triangle right here, but I want you to think about rotating around in a circle here, 360 from here through quadrant 1, 2, 3, and 4. So think about being in quadrant 1, 2, 3, or 4, and I could draw a right triangle. We did that in the previous assignment. But I'm going to focus on 0 degrees, 90, 180, 270, and 360. Those are very key. As you rotate around, here's 90 degrees is there, 180, 270, back to 360. And I'm going to ask some weird stuff. Now, on the radian scale, if I use this fact right here that 180 degrees is pi, so anytime I see a pi, think of it as being 180. Now, so that does remain that if it's a 0 degree angle, meaning, think of this, flat, boom, no angle. There's an angle right there, boom, 0 degrees, 0 radians. 90 degrees would be pi over 2. Think of that. 180 divided by 2 is 90, so pi over 2. 180 is pi, radians. 270 is 3 pi over 2. Think of that as 3 times 180, and then divide by 2. 3 times 180, I believe, is 540. 540 divided by 2 is 270. So there's that. And then 2 pi. 2 times 180, 360. That's 360. So I believe in the assignment we were looking at, they wrote things like the decimals of these. 0, pi over 2, think of 3.14 divided by 2 would be 1.57. Pi is 3.14. 3 times pi divided by 2, I believe, is 5.71. And 2 times pi, 2 times 3.14 is 6.28. So they had those on there. So I want you to imagine a right triangle. Now I'm going to ask you to do some weird stuff with this right triangle. But I want you to imagine a right triangle where the hypotenuse is 1. I chose 1 because it's the easiest number to work with. I told you when I was talking to you, I was like, wow, this is a really big idea that takes a lot of development. So there's something to be said about making this one that we do in pre-calculus and in Algebra 2 as well. But anyway, I want you to imagine, I'm going to ask you over here for the sine of, say I made a chart. We're going to graph this. So I'm essentially, x is the angle. Again, 0, pi over 2 pi, 3 pi over 2, 2 pi. Think of those so you're a little comfortable as 0, 90 degrees, 180 degrees, 270 degrees, 360. I'm asking for the sine of those, and those are weird because we always talk about this angle. We never talk about the right angle, and that's not what we're going to talk about. But anyway, so I want you to think of the theta as being these angles, which is super weird. And taking the sine, which is opposite over hypotenuse. Now, if I start with 0 degrees, now this is going to be weird, but try to humor me. If I took this side, this angle, and scrunched it right down to 0 radians, 0 degrees, there is no opposite side anymore because it's scrunched down, but the hypotenuse is still 1. So opposite over hypotenuse would be 0 over 1, which is 0. So when we go to plot our graph here in a few minutes, so I want you to think of this. This is my x-axis. This is my y-axis. 0 degrees. Think of that as 90 degrees, pi over 2, radians. Okay, 0, 0. There's a point right here. Okay, now this next one is a little bit hard to deal with. But I want you to imagine if this was 1, what if this angle rotated up to make a 90? Now I understand the triangle falls apart at that point, but you still have to think about, well, what if this went up like this? Notice that the opposite and the hypotenuse are taking this, they're this side, because this rotates up into what, this is the opposite position right here, and that side gets so big that it goes right on top. So you're technically doing 1 divided by 1. And by the way, it wouldn't matter if that was 5. If you brought this up here, it'd be 5 divided by 5, it'd be 1. So that's why the sine of 90 degrees, the sine of pi over 2, is 1. And that's a tough explanation, but you have to understand that if I look at this theta and say that's opposite, if I open that theta to being 90, that side's as big as that side. And that means opposite over hypotenuse, you're doing same divided by same. You always get 1. Now the rest is going to be a little bit weird because I'm going to be taking this triangle to another part of the picture. So you have to imagine if I take this all the way over to here to 180, it's going to be the same similar thing as, well, if this angle's squished down to nothing, if I rotate it over here, it squishes down to nothing. So that opposite over hypotenuse is back to 0 again. Now, the 3 pi over 2 down here, I want you to imagine this side rotating down there. Once again, the opposite is taking the position of the hypotenuse. The difference is it's down 1. It's in the negative category. So you have to think that the opposite side and the hypotenuse have superimposed right on top of each other, and that'll be 1 divided by negative 1 because it's down. Remember we did those pictures? I said hypotenuse is always positive, and the other sides are the ones like if it's right, it's positive. If it's up, it's positive. If it's left, it's negative. If it's up, it's positive. If it's left, it's negative. If it's down, it's negative, and all that stuff. And I know this is super bizarre here. But again, it's just like 90 degrees, that this opposite side superimposes itself right on top of the 1, and they end up being the same length. But because it's down, it's 1 divided by negative 1, and we get a negative 1 for the sine there. And then if we go to 2 pi, that's like being right back at 0. That's where the side shrinks. There is no opposite, and the hypotenuse is still 1, so it's 0 over 1 back to 0. So what you find out with sine, and cosine is actually going to be super similar. What you find out with sine is that it just does this alternating thing. 0 to 1 to 0 to negative 1 to 0 to 1. It just sits there and up and down. So if I were to plot these points, and again, remember, these are the radian amounts. They are equivalent to 0, 90, 180, 270, 360 degrees. It's like going around a circle once. pi over 2, 1. Pi over 2, 1 goes there. Pi 0 goes there. 3 pi over 2, negative 1 goes down here. And 2 pi 0 goes here. There's that alternating... They call that a sine wave. And it keeps doing it. Think of that. That's like going around in a circle once. 0, 90, 180, 270, 360. 0, pi over 2, pi, 3 pi over 2, 2 pi. And it just does this thing. Now think about it. If I kept taking this picture around in more circles, like 360 to 720 to... It's the same circular XY axis. This shape just keeps on happening and so on. So that's about as good an explanation I can get without getting into super huge detail. Because I made 4 videos just about this whole idea of this one and why is this sine 0 and why is that sine 1 for my pre-calc and algebra 2 class. And then I made 2 more videos to explain how to start graphing them. So this is a huge idea that you're just throwing in one little lesson, okay? Now I'm going to pause a second. I'm going to just erase this and turn it into a cosine to explain the difference. But I want you to remember, sine always starts at 0, goes up, back to middle, down, back to middle. Sine has that look. Cosine is similar, but a different starting point. So let me pause a minute. Okay, so I changed the graph to being y equals cosine now. And I put the graph back to blank like it was, and I erased the table. We're going to use the same numbers now. Cosine, you know by definition, is adjacent over hypotenuse. So this time, I want you to... So this is the adjacent side of this picture. If theta's right there, this is the adjacent, and this is the hypotenuse. And I told you I made the hypotenuse 1 because it's easiest to talk about that way. It's an easy number to deal with. Now I want you to imagine again if this angle closes... That means the hypotenuse falls right on top of the adjacent. They are one and the same. So when I said what's adjacent over hypotenuse, what's the cosine? It's 1 over 1. They're the same side. They fall on top of each other and cosine perfectly. So 1 over 1 is 1. So you can see the difference in that sine started out 0 radians, 0. But cosine starts out, because you're not talking about the opposite side shrinking down to 0. We're talking about the adjacent side falling on top of the hypotenuse, falling on top of it. So it's like 1 over 1. Now, what you're going to see is kind of a flip-flop of jobs. Cosine and sine kind of just flip-flop their numbers. So I want you to imagine now, if this opens up to 90, this side, as this... Think of this opening up and this just kind of moves over. This side just shrinks to nothing because it goes right to straight here. This side just goes away. So there is no adjacent side over 1. 0 over 1. The cosine is 0 there. And this time, I'm going to erase this. I want you to imagine 180 degrees is over on this side. It's that same thing. Remember how at 0... the hypotenuse fell, this is adjacent, the hypotenuse fell on top of the adjacent, so they coincided 1 over 1. Well, over here, the hypotenuse is still going to be 1, because 180 is over here. The adjacent and the hypotenuse coincide again, but the adjacent's over this way, so the adjacent's negative 1. Hypotenuse always stays positive, so it's 1 over negative 1, or negative 1 over 1, technically. So we get a negative 1 at 180 degrees, also known as pi in the radian scale. 3 pi over 2, 270 degrees, rotating around down to here, is going to take the same deal. Like when this rotated up here, the adjacent side shrunk. Then it grew to negative 1 over here, and now that I'm back down to here, it shrinks again. It's 0 over 1. So it's back to 0. 2 pi, 360 degrees, is like being right back at 0 again. It's got to be the same cosine, so it's back to 1. You're seeing the same numbers, zeros and ones and negative ones, but they're in different positions. So as we plot these out, again, this is the x-axis, this is the y-axis. 0 on the x goes to 1 on the y. That's right here. Pi over 2, 0. Pi, negative 1 down here. 3 pi over 2, 0. 2 pi back to 1. It still has this up and down effect. It just starts on the up. It goes from up to middle to down to middle to up. It's still got that alternating thing, and it looks like this. So that's about as simple of explanation as I can give to that right now. You're going to hear the questions or see the questions ask things about, hey, what's the amplitude of this graph? Amplitude's kind of a read of what's the highest and lowest number it reached, and just give me that. The highest it reaches is 1, the lowest it reached was negative 1. We call the amplitude 1. The amplitude can change based on some things. I'll explain that when we do the assignment. That'll be easier to explain once you have a little bit of this graphing down. There's another thing, I don't even know if they talked about it, the period of the function, meaning this is a periodic function, because you think of it as circular. You think of this rotating around in a circle, and if it went around again and around again, you're on the same coordinate plane, so it doesn't matter how many times you go around. So this is the key shape of cosine, and the shape I had before that went like this is the key shape of sine. They just repeat that little. So if I said keep going, this just goes like this little dippy doop up. Doop, just keeps doing the same thing on and on and on again. So that's about the simplest, without going into huge crazy detail. I told you to get this assignment done in real major detail for my pre-calculus and Algebra 2 classes. It took me 6 videos to do it. So this is kind of the abbreviated version, if you will, to help you maybe have a little bit better idea, and hopefully we can do this tomorrow. It'll be okay.